Ask a language model about your company's refund policy, and it will answer instantly, fluently, and completely made up. It has never seen your documents. It is guessing in a confident voice. That is the problem RAG solves. By the end of this video, you will understand exactly how Retrieval-Augmented Generation works, and you will be able to build a real one in about 15 lines. No framework required. Here is the whole concept in one sentence. Instead of asking the model to answer from memory, you first go find the relevant text, and you hand it to the model along with the question. That is RAG. Retrieval, then generation. You retrieve the facts, then the model generates the answer using those facts. It is the difference between a closed book exam and an open book exam. Same student, far better answers, because now it is reading from the source instead of recalling from memory. The thing that confuses people is that RAG is really two separate pipelines, running at two different times. The first is indexing. This happens once, ahead of time, offline. You take all your documents and turn them into something searchable. The second is retrieval and generation. This happens every time a user asks a question, live. You search what you built, then answer. Build the first one wrong, and the second one can never recover. So let's build them in order. Indexing is 4 steps, and each one is simple. Load. Pull in your raw sources, PDF, web pages, support tickets, whatever you have. Chunk. Split each document into small passages, a few hundred words each. You search and retrieve chunks, not whole documents, because you want to hand the model the relevant paragraph, not a 40-page manual. Embed. Run each chunk through an embedding model. This turns the text into a vector, a long list of numbers that captures its meaning. 2 chunks about the same topic end up with similar vectors, even if they use completely different words. Store. Put every vector into a vector database. That is just a database built to answer one question fast. Which vectors are closest to this one? Do that once, and your knowledge base is ready. Now a user asks a question. Watch what happens. You take their question and embed it with the exact same model you used on your chunks. Same model matters. The question and the chunks have to live in the same vector space, or closest means nothing. Then you ask the vector database for the nearest chunks. It compares the question's vector against every chunk's vector and returns the top few, usually 3 to 5. That sit closest in meaning. This is semantic search. It finds the passage that answers the question, even when it shares not a single keyword with it. Those few chunks are your evidence. You did not send the whole library. You sent the 3 paragraphs that matter. Here is the step the name is built around. You take those retrieved chunks and you paste them into the prompt, right above the user's question, with a simple instruction. Answer using only the context below. Now the model generates, but it is no longer guessing from memory. It is reading your paragraphs and answering from them. The grounding is what kills the hallucination. Ask it something the context does not cover, and a well-prompted model will tell you it does not know, instead of inventing a policy. Retrieve, augment, generate. That is the entire loop, every single query. Most broken RAG systems fail in the same place, and it is not the model. It is the chunking. Chunk too big, and you bury the one relevant sentence inside a wall of noise. Retrieval gets fuzzy, and the model gets distracted. Chunk too small, and you slice a single idea in half, so no chunk holds the whole answer. The fix most people miss is overlap. Let each chunk share a little text with the next one, so a sentence sitting on a boundary is never cut in two. Chunking is where you should spend your first day of tuning, not the model. Once the basic loop works, 4 levers take it from demo to production. Better embeddings. A stronger embedding model finds more relevant chunks for free. Reranking. Pull 20 candidates, then use a second, sharper model to reorder them and keep the best 5. Metadata filters. Tag chunks by date, source, or user, and filter before you search so you never retrieve something the user is not allowed to see. Hybrid search. Combine semantic search with old-fashioned keyword search so an exact product code or error string is never missed. You do not need all 4 on day 1. You need to know which one to reach for when retrieval feels off. Here is the minimal version, start to finish. Index once. For each chunk, store its embedding in the vector database. Then, per query, embed the question, search for the top 5 chunks, paste them into the prompt, and call the model. That is it. Every RAG system on the market, every framework, every product, is this skeleton with more engineering around each step. Once you see the two phases and the Retrieve-Augment Generate loop, you can read any RAG codebase and know exactly what each part is doing. Take one document you know well, chunk it, embed it, drop the vectors in a local vector store, and ask it a question you know the answer to. The first time it pulls the right paragraph and answers correctly, RAG stops being a buzzword and becomes a tool you own. Build that, then tell me in the comments what you pointed it at. The weird internal docs are always the best test. Subscribe if you want the next one, where we take this exact pipeline and add reranking and evaluation so you can prove your retrieval is actually good.